Hello everyone. Hope everyone is fine. Welcome to Maria Virtual Academy. We are going to start a tutorial about VLAN, about trunking and about inter-VLAN routing. And today we are going to start the first part of this tutorial, and this part is about VLAN fundamentals and configuration. As I told you, this is part one of this tutorial. Here are the objectives or contents of this tutorial, part one. We will talk about VLAN fundamentals. And VLAN fundamentals, we will have discussion about broadcast domain, broadcast traffic, the negative impacts of large broadcast domains, or the negative impacts of broadcast traffic in our broadcast domain. Then we will have discussion about VLANs, because we use VLAN as a solution to solve the problems of larger broadcast domain. Advantages of VLANs will be discussed. Types of VLANs will be discussed. In types of VLANs, we will have discussion about static and dynamic VLAN. And also we will have discussion about types of VLANs based on purpose, like data VLAN, like voice VLAN, default VLAN, native VLAN, and management VLAN. At the end of this part one tutorial, we will have discussion about VLAN implementation. And VLAN implementation, we will talk about how to configure VLAN. Based on what we can divide our larger broadcast domain into smaller broadcast domains, into smaller VLANs, and how to assign ports to VLANs. Because we will create static VLANs, and you know this, that to static VLANs, we will assign Ethernet ports as a member. So these were the part one contents. Let's start it from the VLAN fundamentals. VLAN fundamentals. First of all, we have to understand what is broadcast domain. A layer 2 switch network, a whole layer 2 switch network, or a segment of a network, layer 2 switch network. Maybe some organizations will have a larger network and they will divide their network into multiple physical parts. So then that segment, that physical part will be known as a segment. So a broadcast domain can be that segment, or a broadcast domain can be the whole layer 2 switch network, where broadcast will be created by the switches, and the broadcast will be spread among all the unknown active ports of the switch, and will be reached, and this spreaded broadcast will be reached to all unknown computers, host computers. So we understand that the broadcast domain means it can be a layer 2 switch network, or it can be a segment of a physical network where the broadcast will be created by the switches, and the broadcast will be spreaded by the switches on the all active unknown ports. Unknown ports mean because the switch will have no idea that which computer is connected with this port. Because the switch will avoid sending broadcasts to those ports on which the switch already have registered a MAC address in their MAC table. What is broadcast? Broadcast is a data traffic. It's a data traffic. With the help of this traffic, the switch will try to find the appropriate destination. among the all unknown ports. But remember, these unknown ports will be only consist of active host in a network, okay? It means active ports are those ports to which we have a connected host computer. What are the negative impacts of this broadcast domain? Broadcast traffic in a broadcast domain will cause the following problems or the following negative impacts. The first negative impact is the performance of network will be decreased. And you know that performance is a very important factor for the productivity of your organization. And this factor will be disturbed by this broadcast domain, by this broadcast traffic. If you have more amount of broadcast traffic, that more amount of broadcast traffic will consume your more resources, like they will consume your bandwidth, they will consume your switches resources, like their CPU, their memory, and other buses. So ultimately, the performance will be decreased because your resources will be consumed by somehow useless traffic. Efficiency of devices will be decreased. Efficiency of devices will be decreased mean your devices capacity will be wasted by the broadcast traffic. Whenever devices are going to send some useful traffic, so sometimes they have to face the congestion of broadcast. And because of this, we can say the performance will be affected because the useful traffic face the congestion of broadcast traffic. And beside this, the efficiency of devices will be decreased. The device's capacity will be wasted by the broadcast traffic. And whenever the capacity of devices is wasted, so we can say the efficiency problem arises. The next problem is security problem. We know this, that whenever the broadcast is going to be generated from a computer, the broadcast will be reached to this, okay, whenever the request, let's suppose in this topology, let me build a topology. For example, I have two computers here, and these two computers are connected with the switch. Okay, let me add another computer. Okay, this computer is going to ping a computer, for example, 1.5, okay, the last 2 octets. So they will send the request to the switch. The switch will try to find the 1.5 computer for him. So they will generate word. The switch will generate broadcast. So the broadcast will be reached to the all unknown active ports, or okay, and to the active host computers. What will happen after this? The IP address of this computer and the MAC the IP address and the MAC address of this computer will be exposed to those computers, because you know that this computer will add their IP and their MAC. If you have idea about TCP IP, because this computer is going to use all the layers of the TCP IP model. So at network layer, they will add their source IP, and the data link layer, they will add their MAC address. So these two addresses will be exposed to all these computers. And you know, whenever the address is exposed, so then the other computers can use it for any purpose. So it can be harmful. There is a potential risk of security, okay? So for this purpose, security problem will be also arise. Because of what? Because the IP and MAC of the source computer will be exposed to all those computers who receive the broadcast. And the last problem is manageability. A single larger broadcast domain management is time consuming and difficult compared to a network which is divided into multiple smaller broadcast domains. So these were the drawbacks or negative impacts of a broadcast domain. But remember, a larger broadcast domain. What is the solution? The amount of negative impact is depends on the size of broadcast domain. It means there's the ratio of negative impact or the scope of negative impact is depends on the size of broadcast domain. If you have a broadcast domain consists of 2 or 3 or 4 switches, it will be okay. But what if it is consist of tens and 20 or 30 or 50 computers and all of them are operating in a single broadcast domain? Then imagine the amount of broadcasts and ultimately imagine the negative impacts and the performance and efficiency of your network and device. If broadcast domain is larger, they will more affected. What will more affected? The network. Because of the larger broadcast domain and there will be more broadcast traffic and the network will be more affected. Solution is what? Solution is the logical segmentation or division or partitioning. So we have to divide the single larger broadcast domain into multiple segments. But you know this, that we can do this segmentation physically and logically. But the optimum solution is here to divide your networks into multiple smaller logical segments or partitions while dividing the single larger broadcast domain. Okay. Layer 2 switch network into multiple smaller virtual lanes, or you can say broadcast domains. So we understand the solution is what? Dividing or breaking a larger network into smaller section by implementing what? VLANs. So we understand that the solution was to divide the larger broadcast domain into smaller broadcast domains. But why what? Why VLANs? So VLAN allow segmentation. You can say VLAN support segmentation or breaking a larger network into smaller ones. So it means with the help of VLAN, we will divide our larger broadcast domain into smaller broadcast domains. What we need for the VLAN creation? We need layer 2 switches because VLAN is a layer 2 segmentation. VLAN is a layer 2 segmentation or layer 2 partitioning. With the help of VLAN, you can divide your layer 2 switch network into smaller virtual broadcast domain. And you can do this division based on multiple factors, you can do this based on departments, based on the projects, based on applications, based on purpose, etc., etc. Okay. A VLAN is a logical partition of layer 2 switch network. We have idea about this. The partition of layer 2 switch network take place inside layer 2 devices, usually a switch. You don't need any extra device, only layer 2 switches, which is already there in your network. Access them and configure VLANs. Each VLAN is a broadcast domain. Each VLAN will be a broadcast domain. It means that let's suppose you have 4 computers in a VLAN. So the broadcast of these 4 computers will reach to each other. Okay, the broadcast will not spread to other or reach to other VLAN because each VLAN is by itself a broadcast domain. And usually the VLAN will have their own subnet. VLANs are mutually isolated. It means if you have 2 VLANs in your network, both VLANs are isolated from each other. The packets will not pass from one VLAN to another VLAN until we enable inter-VLAN routing. Types of VLAN. There are two main types of VLAN based on configuration. The first type is static VLAN. The second type is dynamic VLAN, where the static VLAN is also known as a based on port number. So it means that when we create static VLANs, we should assign port numbers as a member to that created VLAN. And this assignment will be done manually. We have to select the port. Next, we have to assign them to the specific VLAN. So based on this about two features, we can say that static VLAN is also known as a port-based VLAN. Remember that one port can be a member of only one VLAN. When you change the membership, then the port will lose the previous VLAN membership. The next is dynamic VLAN. Dynamic VLAN is based on MAC address of a PC. It's not based on port number. We have to specify the MAC address of a computer to a VLAN as a member. So whenever a specified MAC address is detected on any port, that port will automatically become the dynamic VLAN member. Here, it is possible for a port to be the member of multiple VLANs, but not at the same time, because at the same time, they can only support the connection of one computer, okay? Not at the same time, but in different times, they can be the member of multiple VLANs. For dynamic VLAN, we need VMPS server. VMPS, which is a VLAN membership policy server. So these were types of VLANs, but based on configuration, okay? Based on purpose, we have 5 types: data VLAN, voice VLAN, default VLAN, native VLAN, and management VLAN. Data VLAN is for computers. Whenever you want to your computers or your user generated traffic should be carried by a particular or inside a particular broadcast domain, so then you have to create data VLAN. So voice VLAN is for voice over IP telephone sets. Whenever you want to carry your voice traffic by a particular VLAN, so you have to create a voice VLAN. Default VLAN, every single switch have a VLAN by default, and that VLAN is called VLAN 1, and the name is default VLAN. The native VLAN a native VLAN is a VLAN which support the trunk ports and which support all those ports which are not part of any created VLAN. Management VLAN, whenever we use VLAN is a SVI, the switch virtual interface. For management purpose, that VLAN will call management VLAN. Dear all, in our topology, we will just work on data VLAN and native VLAN.